There comes a time in every mathematician's life where you're asked to find the definite integral of something and you've got no clue how to do that. Maybe it's because you don't actually have a function. Maybe you just have a few points. Maybe it's because you just don't know how to integrate something. So you've got to find a different way of doing that. But whenever you go for estimation, the best way is to probably use a computer to do these estimations. But essentially what you'll be trying to do is add up some Riemann sums. Yes, we've done these before. The left-hand Riemann sums, the right-hand Riemann sums, the midpoint Riemann sums, and of course, from chapter 4.6, there is the trapezoid method also. Okay, there is another one that I may or may not go over in class, depending upon time. It's called Simpson's method. It's even more accurate. So when we look at the accuracy of these, generally, the midpoint and the trapezoid are the most accurate, and the left and the right hand are generally the least accurate. However, whenever you reach an infinite number of things or a larger number of rectangles or trapezoids to add up, the more accurate your estimate will get. And believe me, it is okay to do estimations with these. If you want a definite integral, you can just add up a whole bunch of rectangles and be very, very accurate. Now, if you're actually adding some of these up, I'll start with the left and the right hand methods. I'm going to go ahead and tell you that the number of intervals you should use is 4. And this blows some people away because they're looking at this going, wait, there are 5 numbers. Remember, these are intervals. We're adding up rectangles. They have a certain width. The first rectangle will go from 1 to 3. The very next rectangle, we're not going to leave a space. It's going to go from 3 to 5. The third one will go from 5 to 7, and the fourth one will go from 7 to 9. So take a moment and estimate the left and right hand Riemann sums for this table in part A. And that's pretty humorous because I did not mean for the right-hand limit to approach 0. Please note, what's the only difference between these? Well, this rectangle, the second rectangle, and the first rectangle are exactly the same. Every single rectangle you're adding up is absolutely the same, except for the first and the last. Because one of them is going to start with the rectangle far on the left and one from the information far on the right. So that's the only difference that you're actually going to see here. But, and if you want it more accurate, use more rectangles, more spaces in between. If you only have a table of values, you have to use what is there. As a matter of fact, these don't even have to be equally spaced. You could have rectangles that have a width instead of 2, 2, 2, and 2. They could be 1, 3, 5, 2, 4, and 7. No big deal. Now, we also have one that is called the midpoint method. And for this, then they do have to be equally spaced, or I have to have enough information where you can actually find the midpoints on there. Go ahead and try and find the midpoint Riemann sum for that table. Please note that with 2 intervals, we're going from 1 to 5 and then from 5 to 9. To do the midpoint method, the midpoint between 1 and 5 is 3. So the height that we use is whatever function value is given at 3. Same thing here, from 5 to 9, 7 is the midpoint. We're going to use that y-coordinate at 7, f of 7, and that's how we find the midpoint. So you may be wondering which one is better, the midpoint or the trapezoid rule? It turns out, even though the midpoint rule looks like it's way off, if you cut out this little triangle that's an overestimate and put it on the second half that's an underestimate, the midpoint is usually more accurate. Both of them are very good. You'll see that with the trapezoid rule, if you have something that's concave down, your estimate is an underestimate. And if it's concave up, you'll have a slight overestimate. But once again, most of the time the midpoint will be better. However, there are occasions where the trapezoid rule works better. They're both very nice. I don't have a particular preference, but oftentimes you'll be asked questions specifically about one or the other. Now, coming back to our problems, I don't want to forget the fact that we had this second one, part B. How would you do these estimations with a formula?